Yeah, hello everyone.
All right. Yeah, great. Nice to see everyone. Thanks for joining us today. Let's see here. Yeah, so my name is Dan Island, and again, we're very happy to have everyone here um, and to join us for our hot topics in the data science panel, which is hosted by the UCF Big Data Advisory Board. I am the Associate Director of the Masters of Science in Data Analytics program, and I'm going to be the moderator for this panel. On behalf of the Big Data Advisory Board, I would like to thank everyone again for joining us for the session. The Big Data Advisory Board consists of a large and active group of dedicated and knowledgeable alumni and industry experts who strive to really provide incredibly valuable insights that improve the exposure and the excellence of the data science programs here at UCF and in the community. While the board has been involved and engaged with the Big Data Symposium in past years, this year the Big Data Advisory Board chose to use this speaker slot to prioritize connecting the dots with industry. And during this panel today, we're going to explore some hot topics in data science that will align what students are learning in the classroom to the timely topics affecting the work being done in industry. So we are grateful to be able to gather virtually here safely to hear firsthand insights from our incredibly accomplished panelists from a variety of fields. So we're going to start by hearing and learning about each panelist, and then we're going to dive into questions that have been compiled by the UCF Data Science Board's Outreach and Speaker Committee. Before we introduce our esteemed panelists, I want to go over a few housekeeping items. This event is being recorded. And following the initial discussion, we will have, just like the last speaker was Zach, we will have a dedicated time for Q&A. But at this time, we welcome all of you to ask the panelists questions. But please use the Q&A function to ask the panelists questions, and you can upvote any questions you would like to hear that you may see. Okay. So, oh, this is not me. Okay. Let's we're going to jump over to our panelists here. But first, I would like to acknowledge the students from across the campus who are invited to learn and participate today. We have many students from degree programs in the College of Science, the College of Engineering and Computer Science, and the College of Business, studying at both the undergraduate and the graduate level, including our excellent PhD programs that Dr. Zhang had mentioned. We also have students and community members joining us who are considering studying data science. And I want to acknowledge and thank all of you for joining us today. And now, without further ado, I would like to introduce each of our panelists. First, Dr. Sharna Parkey, who has an MS and a PhD, is the data science lead at Cascada, where she works on the company's product team to deliver commercially available data platforms for machine learning. She's passionate about using data science to combat systemic oppression. She has over 15 years of experience in data science and adaptive algorithms in the defense and startup sectors, and has worked with dozens of Fortune 500 companies in her work as a data scientist. She earned her PhD in electrical engineering at UCF. Welcome, Dr. Parkey. Next, I'd like to introduce Kevin McCormick. Kevin is the principal investigator for the U.S. Air Force CBM Plus programs for Lockheed Martin RMS. He earned a BS degree in computer engineering technology from Rochester Institute of Technology and is the co-founder of 4 U.S. awarded or pending patents in the field of CBM PHM. Kevin is focused on making data easier for customers to use and cultivating an environment where people are challenged and enjoy what they do. He leads multidisciplinary teams to develop and deploy analytics supporting sustainment initiatives like Condition-Based Maintenance Plus, where data is used to predict machinery health so maintenance can occur at the time of need. Welcome, Kevin.
Thank you.
And Dr. Medea, yeah, and Dr. Medea Jaffrey. Dr. Jaffrey received her Bachelor's of Science, her Master's of Science, and PhD in Electrical and Computer Engineering from Old Dominion University in 2003 and 2004 and 2007, respectively. Fully funded by the NASA headquarters, her accelerated PhD studies became the first pioneering work that used artificial intelligence to predict electromagnetic interference on commercial aircraft. While pursuing her doctorate, Dr. Jaffrey also completed postdoctoral research at the Olin Neuropsychiatry Center in Hartford, leading another first of its kind solution in the classification of schizophrenia using AI on fMRI data. Dr. Jaffrey joined Lockheed Martin in 2007 as the lead cryptography expert, designing complex cryptography solutions for NSA certifications. Alongside cryptography, she served as the lead systems engineer, co-developing patented concepts in nanotechnology for weapons and medical signature detection. She also served as a cybersecurity manager in infrastructure engineering and is now an associate fellow leading digital transformation and AI intersections across Lockheed Martin's portfolio, while keeping cybersecurity and ethics at the forefront. Welcome, Dr. Jaffrey.
Thank you so much for having me.
Yeah, well, thanks everyone for being here this morning. Now let's dive into our questions. Colleagues here today, now don't forget, if you do have a question of your own that you'd like our panelists to answer, please feel free to type it into the Q&A function at the bottom of your screen. And this is an important topic that we're going to cover here today because a lot of our population that's listening to us now across the ether are either in data analytics or interested in data analytics. So, the types of things that we're going to discuss are pivotal to making that transition from learner to practitioner. This is in the ever evolving field of data science. It's important that practitioners, are learning and being able to deploy the latest techniques and the most appropriate technology solutions to solve very complex problems. And that's what the mission that we have as a university, and these are the things that all y'all are doing every day in the real world. So let's start off our panel. I'll pitch a question here to Kevin. Speaking of those skills, Kevin, what are some soft skills that can best assist a data scientist in becoming successful in their role as a professional?
Soft skills. Now that is something that that is really important in industry and that probably the toughest to teach while at university. But there's definitely things that I've observed that are really helpful in this industry. And besides the basics of critical thinking, listening, being adaptable, and trying to communicate very effectively, one that I've particularly found important in the data science and analytics and machine learning space is empathy. And what I mean by that is oftentimes we are brought in to help solve a problem. And us as engineers or scientists want to say, okay, give us the data, we'll give you that output. That's exactly what you're asking for. Well, a lot of times there's some unintended consequences that occur in those cases. And it's required that you empathize with the people that you're working with to try to understand what it means when, they give us all of their data and we say, hey, based on all of your data, you need to go replace, 1,000 of these parts. Well, what happens if they only really have like 10 on the shelf and none are going to be available for the next 8 months? That could be a shock to existing supply chain systems. So being able to empathize with the people that your customer or those subject matter experts is absolutely paramount to get acceptance into the approaches that we have.
Yes, so that's what I mean. Empathy is important, of course. I I would pitch the same question to Dr. Parkey, if she had some thoughts on this.
Certainly. Yeah, I think from a perspective of, I've been a data scientist myself, and then I'm building tools for data scientists now. And one of the themes that I'm hearing across, industries it doesn't matter what you're working on, whether it's fraud detection or making games or something like that. It's, it's on the vein of empathy, but learning how to ask questions that are curious and get at the heart of some of the challenges you're trying to solve. Because fundamentally, the models that you're building, whether you're analyzing the past or you're looking to build a model for the future, it's a human problem you're generally working on. Even when we're doing things like measuring things for climate change, et cetera, there's the data that we're generating and collecting are made by humans. I think in the first talk, we heard about how the data is never clean. And if you expect it to be so, you're going to have an issue. So what are the questions that you need to ask? Learning how to ask those questions to get at what your data can be used for versus what it cannot be used for is incredibly important.
Yeah, so that's great. And just to sort of parlay on that question a little bit, empathy is important, and being able to ask good questions are important. But Dr. Joffrey, if I can pass this question to you, considering all of the different aspects or the wide-ranging impact that these types of applications can have on many different business units. I mean, what are the pros and cons of becoming a specialist in a particular field of, let's say, machine learning, or becoming a more of a
as everybody talks about artificial intelligence and machine learning, and as you saw from my background, right, there's so for my PhD I solved an electromagnetic problem using artificial intelligence, and then for my postdoctorate I solved a biomedical problem. It's schizophrenia using artificial intelligence. So two very different domains, but similar solution. And I think so over the years we're learning that, I mean, so yes, AI is a tool, right? And we need folks to obviously focus on it and enhance the algorithms and the models, but we definitely need the generalists as well. The people who were focused on the domains, whether they're the radar experts or the cyber experts, or focused on EW, or I mean, I've even talked to fashion designers, right? So everybody needs to embrace AI, and the domains that people have pursued because they're passionate about, whether it's something in art or history, is not replaceable. I personally, this is a biased view, I personally feel that it's easier to pick up the AI ML skill sets versus picking up the domain skill sets. So we need to continue to build this technology, and so I would say that, so there's definitely, I know a lot of STEM students come out to me when I mentor, or even, very seasoned engineers would come to me, who have like 15 to 20 years of experience in building something or a product. And I always say that don't switch over completely, stick with your domain, and then, learn to apply AI on top. So it's just, I'm all in favor for generalists as well as specialists.
Sure. Kevin, do you have any thoughts on that question?
Yeah. As much as I'd want to combat and have a discussion, I really agree with Dr. Joffrey. The generalists are the connective tissue a lot of times in projects. I work in the military space, right? And we're a little bit behind industry. So if I had somebody who was a pure data scientist or pure deep learning or just focused on deep learning, could I have them jump on one of our projects and help us? Yes. But a lot of times it's better to have somebody who can understand the full pipeline, including perhaps the subject matter expertise on the domain that we're actually talking about. We have, because data science is relatively new, this might be a biased take, but I think the most effective people that I've observed on my team are not pure data scientists. They're mechanical engineers or electrical engineers or physics, applied math students who have taken an interest in learning Python, AI, and machine learning. And the folks who do come to me with a data science degree, those who have a software background, perhaps a double BS within computer science or software engineering, or something to just add that flavor of either software background or having that domain engineering science background outside of data, has been a really powerful combination to make it really easy to have people join the team and contribute in meaningful ways.
So I mean, that's great. I mean, you brought up an important point here that there is a lot of change in this space. Data science is becoming by the day more ubiquitous. And as you juxtapose that against the importance of the domain knowledge that we're discussing here, Dr. Joffrey, I wonder, how has, in your experience, being multimodal here, how has data science evolved over the past few years from what you have seen?
Yeah, I think, because I've been, my PhD is almost 14 years old now, and I would say that when I got back, so, at Lockheed, I was focusing more on cybersecurity and other things and not necessarily AI. And then I got back into AI about 3 years ago. And I was very terrified that, oh my gosh, I'm very much outdated probably, right? And basically it's a shift in new terminology, like in my dissertation, I just called it neural nets, artificial intelligence, now there's machine learning and deep learning. So, just fancier words and new terminology, but there's definitely better models out there, right? And I think those models are enabled by the new technology. So we have a lot, powerful technology. There's also a better diversity of thought. There's more focus on bias and ethics, that wasn't there before. There's also a breakdown of silos, and then of course there's that more appreciation of the generalists, so instead of just going in there and just becoming a data science person, it's you have to kind of understand the bigger picture. So there's so I love it. There's so much new stuff happening over the 14 years. I've really seen that there's it's definitely going towards the better, and it not just in diversity of thought, but also just diverse branches of data science. So it's exciting.
So just to follow up on that question, I mean, what are some of the macro factors that are driving this evolution that you've seen?
So there are many. I would say that like for example, and again, I hate to keep using myself as an example, but back in my days, right? My PhD had to be in electrical and computer engineering, even though it was focused on artificial intelligence. There was no other choice. Modeling and simulation, a degree in modeling and simulation was like the new thing back in the day, like, and only one university offered it, right? So you couldn't really specialize. You had to. I knew all about power and circuits, and then there I was trying to, learn AI as well. So now I think that there's such a better focus in data science in colleges and universities and online. There's so many certifications and trainings that you can take. So I feel like the education, the training, and the awareness is much better now. And then the other huge driving factor is computation power. For my dissertation, I remember, with my all my data, I had like a really sad 3-layer neural nets, with like 21 nodes. That's all my little, laptop could afford at the time. So now, it's just that there's no limit to our models, right? So it's that's really exciting, and I think that's what's breaking ground in so many ways with AlphaFold and all these other solutions out there. It's just like I see it, I'm like, oh my gosh, I couldn't even imagine these solutions back there. So I would say those are the two primary drivers. I think computation power and just the formalization of training and awareness.
And I think something that to add on to that, several years, maybe 8 years ago, we had a whole bunch of fleet data, a whole fleet of aircraft data. So imagine black box data from like an airplane, a whole fleet of it from hundreds of aircraft, right? And we're trying to figure out, how can you process all of this fleet? How can we interrogate this fleet dynamically as we want? and have it not take several days to get the result, right? So we slapped together a few old intern laptops and developed our own, created our own little mini cluster. Proof of concept worked great, and now we have this massive on-site Hadoop infrastructure that we can very quickly interrogate our entire fleet of aircraft for whatever we want. And it's really great. And I know Sharna brought it up earlier that she works on tooling as well. And part of that evolution is going from the state of, hackerish type people, installing these open source tools on bare metal, to now this massive influx of new applications and tooling that is meant to help subject matter experts do things like create machine learning models, in a graphic, in visually, in a GUI, not having to do any programming. So that shift has been really interesting to observe over the last, 10, 15 years or so.
Yeah, one of the things you get to do when you're changing the way you solve the problem from sort of, I compare it from a DevOps perspective to an MLOps perspective. A developer operations person is asking, how do I make this one thing faster to iterate on? And I need to fully specify what that is. It's all about automation. But machine learning operations, data science operations is more about, how do I get the information a data scientist needs to be able to change their model? And that's a fundamentally different problem. That says, okay, I need to be able to provide them any kind of data, whether it's relational data, event-based data, streaming data, connect those things all together and provide it to them in a way that they can interrogate it, right? And if they can't, and you have to build a specific data pipeline for every single question that you need to ask, then you're kind of slogging through, and it's very hard to iterate as we just continuously start collecting more kinds of data, et cetera. And so, yeah, we're seeing the shape of the data change, and we're seeing the way that we can actually get data scientists connect to it change.
So Dr. Parkey, that leads me to my next question on my mind. We're talking about sort of the juxtaposition of the domain expertise versus the democratization of data science because of this computational power that we have more access to. But so, Dr. Parkey, what do you think is the next evolution in data science? Like, where do you see this field going?
Yeah. There's been a conversation and a lot of things happening around ethics, around bias. And I think my perspective on this is along the vein of accountability. So we see a lot of companies releasing models that are making impacts across different groups, but not being required to report on that impact, right? There's only certain regulations in certain industries. But it turns out researchers and individuals are able to expose when things are happening. And I think we're going to be seeing a shift in the amount of questions that are being asked, how people are being held accountable for the things that they released, but also in the way that an individual data scientist can measure at the moment that they're building and continuously measure while their model is out in the world. You may have seen in Florida the data scientist that got fired for refusing to manipulate data, right? There are no protections right now for data scientists doing whistleblower activities like that. It's not technically whistleblowing when it's not on certain types of data. So we're going to see huge shifts in empowering individuals to be able to hold companies accountable so that they can actually kind of prove out that this is happening, and it's not going to be optional. That's my belief.
Yeah, so that sort of keys my thinking on a follow-up question for you, Dr. Parkey, if you want to hold on to the mic for one more second. Yeah. Why is there a need for these ethical guidance or standards in this work that we do?
Yeah, I mean, I come at this from a behavioral science perspective. you can do a series of ethical checks to see not just, is it possible to answer a question, but should I? There are, we saw a trivial example a long time ago where it used to be like TV shows had cigarettes in them and they were marketed to children and stuff like that. And, you need to check, not only are you about to introduce a model that will change a person's behavior, but does it align with what they would want to do? If you are getting someone to jump off a cliff, that's obviously bad. But where is that line? And so you have to find a way to use behavioral design or ethical checks to understand, is this something I should be doing? And then on the other side of that, you can't possibly check every single person's values to see whether or not you're going to do something accidental. And so you have to continuously measure what your actual impact is, because your models don't exist at a fixed point in time. The world changes around them. And so as the world changes, even if nothing about the shape of your data has changed or your performance has changed, that doesn't mean that the impact of the model that you put out there hasn't changed. So that's a fundamentally different vector that we need to be measuring.
I think the line is candy cigarettes.
That's, yeah.
Well, let's talk about that line, Kevin and Dr. Joffrey. I guess I'll bounce this ball to Dr. Joffrey. I mean, considering that you've been sort of at the tip of the spear in this space, and now that you work, in the DoD realm, I would be very interested, to hear about your perspective on the ethics.
Exactly. Yeah, that's I think Sharna hit the nail in the head. Like with the we are used to ethics. Ethics has been a part of our culture forever, but traditional ethics has been very siloed, right? There's this ethics department, and they lay out their training, and they say, don't do sexual harassment, or don't do thou shall not do workplace violence, right? So there's that kind of ethics that the corporate world is used to. But then when we talk about AI ethics, it's when we talk about bias, or what happened with like hiring based on race, racial hiring, or that misclassification, facial misclassification. It's not that we can lay out the rules that thou shall not create algorithms that are racist or sexist, but that's just not what happened. It was exactly what Sharna was saying, that there's these models evolve, and so how do you make how do you make our models accountable for ethics? So it's not just laying out a standard and ethics principles, which I think a lot of our companies are doing a great job at, because we're used to coming up with those integrity-based rules on don't do this. Our companies have ethics, but these undesired biases occur, and the way to tackle that is to have diversity in the workforce. So that whole because that diversity is the checks and balances with our engineers. So you have two engineers designing the same thing or similar, working on the same project. Somebody may raise based on their experiences something completely different that the other engineer didn't think about. So you almost need that checks and balance ingrained in your culture. So I think it's so there's definitely a need, of course, but embedding that that culture is a challenge that I think we should have been tackling for years. We are behind. The entire industry is behind on ensuring that we need to cultivate our. And then as far as you talk about DoD, a lot of people are concerned about ethical use of our equipment. And I guess what gives me the comfort is that of course US and UK, our allies, we have ethical principles in the works, but what gives me comfort is that our some of the countries like China, Russia, what they don't have is diversity in their workforce. So it gives me peace that when we give, or it keeps me up at night for what the other countries are doing, because they don't have these checks and balances versus what we have. We do have the checks and balances. We just have to cultivate the diversity and keep pushing this this point.
That's great. So, speaking of, the I guess the global reach of this, or how different countries are making a sort of a different decisions, with these techniques and how they're deployed. This is, as you articulated, this is a worldwide phenomenon, and looking at that global level, we're coming out of a very dark period, because of the pandemic and how that has impacted our the human race on the planet. But as you articulated, we're all handling it differently. How do you see? Let me bounce this ball to Kevin. How do you see data science sort of influencing these global economic trends, and can data science survive the cut in a downturn, and why?
Yeah, I think it's a great question, and it's a very practical question. My take on it is that, at least from my view of the world, a lot of the work that we do in the data science, data engineering, AI and ML space is about cost avoidance. So if you're feeling budget pressures, if the Department of Defense is feeling budget pressures and things need to get cut, you need to do things more efficiently. A lot of times, the best answer is utilizing the data you have to make more informed, better informed decisions. So we've been doing this, survived a couple downturns, I think, and every time we're at the bottom, it becomes obvious the value that being in this domain has is obvious. It's all about, for us, cost avoidance through analyzing your data and becoming more intelligent and knowledgeable about your situation and making better decisions, which will always be supported when you're feeling budget pressures.
Yeah, so we talk a lot about the data science sort of finds efficiencies in the margins, right? You expand those margins, and it's it can be complicated, to explain those predicted outcomes. But I guess let me bounce this ball back to Dr. Joffrey on this. When you're as data scientists, we're usually the smartest people in the room, but how do you explain these complex machine learning outcomes to colleagues, particularly if it's a complicated issue and might be hard to even describe or understand yourself as a practitioner?
Yeah, that's such a good question. And I guess now that you worded it like that, I would have two answers to that. One is that, one is that I think, again, back in my days, communication wasn't that emphasized, right, in colleges, right? So, but now this whole concept of art and just presentation skills in general, but for STEM to become STEAM is super important. I think people use very different means to communicate very complex ideas very simply, and I've seen that happen so brilliantly with our new workforce coming in, that they definitely use art to communicate some of the complex solutions. And the other thing I would say about the models themselves is that I like to say that features are in the eyes of the beholder, right? So like the features that the data scientist has extracted, whether you're using simple clustering or neural nets, or whatever model you're using, it's so important to be able to extract those features and explain just the features to our customer, that this is what, and if you just focus on that and just emphasize, why did this algorithm focus on the color of the skin, or the names of the people? What is it seeing in all these names? Is it, oh wait, all these names are female, or something like that. So just to figure out what are those features is super important. And I think that kind of gives more trust, I think, to just that explainability part, gives more trust to the customers in this black box kind of a solution, in this black box world.
Yeah, yes, it's hard to explain. Dr. Parkey, I mean, you have an interdisciplinary background and you work in interdisciplinary teams. I would love to hear your opinion about that as well. I mean, how do you explain these complex AI outcomes, to the colleagues on your teams that you work with?
Yeah, so it depends on the model you're using, right? Some are explainable. Some you can say, here are the features, right? You've engineered the features, you put them in, you can show what the model is deciding. But others you can't. So things like deep learning, you're not sure what it's learning. And so my PhD is in digital signal processing, and this is, to me, a system identification problem. And so you can create a set of training and testing and validation sets that allow you to isolate after the model has learned something, what is it that you're asking it to now predict, right? So you could say, like, say you give it a bunch of pictures of sheep in a field and like cows in a farmhouse or something, like they've got a building around it. How do you know whether or not, when it gets a new picture of a sheep, that it's going to call it a sheep? And maybe that sheep is in snow. Did it identify grass or did it identify the sheep? And so you can do things by iterating your data that the model has never seen before to better understand what it actually learned. And this is a very complicated scenario with deep learning, right? Because you have to kind of search the space, create minor variations in order to understand what it learned. But I think you have to do it. So doing that alongside of what I mentioned before, measuring the actual impact over time, we call it disparate impact. When you have two different groups, it doesn't have to be demographics of people. It could be, you're building a revenue prediction model and you want to say, like, maybe your model learned that the enterprise high value contracts are more likely to be successful versus your small to medium business contracts. That could just entirely be because that's a higher value contract and you spend more time on them. So how do you know whether or not you're treating those customers differently? And that's what's creating the prediction. Or it's actually that those customers are using your product more successfully. And so you have to find ways to measure disparate impact on the groups that you care about, and then walk back that decision. Why did it learn this? What did it learn? Why did it learn it? What will happen if I change this thing? By kind of doing a system identification, controlling your inputs, looking at your outputs, identifying what's in the middle. So that's usually sort of the framework that I walk customers through when we're talking about it, because, oftentimes it's not even just that you have a black box model, it's your data scientists aren't with the company anymore. And now you have this model and you have no idea what it does and what can you use it for. Seems like it can answer this question. Can't I just use it over there? Well, maybe not. Maybe not. So
dangerous J word.
Oh yeah.
So I'm going to do something a little bit different here. I do have a few more questions, but I'm going to pause to see if there's any questions from the audience. That maybe our conversation up until this point has spawned. So I'm going to pause here for a moment to see if we can take some Q&A. I'll monitor the chat. All right. I'll float another question out there. Oh, here's one. So here's a question from the audience. Do you think there should be open to everyone, do you think there should be a stronger ethics component in data science programs?
My answer is a yes.
Agreed.
Yeah, I mean,
go ahead.
Just to understand, to acknowledge that you could have a profound impact on outcomes that you can't really control. So being aware of that sort of responsibility is really key.
Yeah, I think there are two ways I've seen universities approach this. It's like, all right, let's give it a specific ethics class. Like maybe let's study IDP or something like that. And that's good. That's giving them sort of some time and space to think deeply on ethics. But I think every single project, every single class needs to have a component of the work that brings it in, instead of having a single point in time where this is thought about. Same with, the data cleaning that we talked about before. This is something that if it is clear from the moment that you start this program all the way through every class, every interaction you have, this is a constant concern, then it will be less of a surprise that as soon as you get into a business that is top of mind, right? A lot of times we see, PR firms are trying to make things go away after the fact, but there's a focus internally at companies of not making it into the headlines for these reasons. And so you're going to have to ask and answer a lot of hard questions when you want to put a model out there. And so it has to be top of mind all of the time.
Yeah, I would second that. I guess piggybacking off of that, right? I mean, we're talking about artificial intelligence, and I know that the the position that Dr. Garibay, our lab director, takes, is that we are we're optimistic about the future of artificial intelligence and the role that plays in society. However, how this is let me I'm looking at Dr. Jaffrey here. Knowing this and knowing that there is some consternation around artificial intelligence, what will the impact be in your opinion, in your company vertical, or more broadly? How will machine learning impact the number and the types of jobs that you're going to see, that you're going to need in the workplace?
Yeah, I can answer it a little bit for the defense industry, but I would say that it's really applicable to everything, right? But I mean, from a Lockheed Martin perspective, our portfolio is huge, right? We are the largest defense contractors in the world. We have products in space, we have from landing on Mars to we have products in air, in sea, on land, on undersea, right? So we have products everywhere that obviously will need enhancements, and then we also have need to insert efficiencies throughout our businesses, right? So it's not just in the product aspect, but also whether it's the communication. How do you communicate with a company that's over 100,000 employees better? How do you provide a better supply chain, better HR, so as we go through this digital transformation, we'll need to leverage skills in each phase of the MLOps pipeline. And it's not just we've kind of touched on it throughout this talk today. From soft skills to technical skills to just technology and understanding how is this new hardware. If you look at the AI landscape out there, there's new products coming out every day. How do you sift through that? What is good for your company? Again, back in the days, we could just invest in one tool, MATLAB, and that was it. Like everybody got MATLAB, and that was it. But now it's just like now there are these new and latest things that you can, and so many things are free, but are they secure? And so we need more security as well, more emphasis on security too. So yeah, there's just all kinds of skills that are needed. So keep. I mean. I'm looking forward to connecting with more students and everything, because we need them. This is awesome.
Yeah, and I don't see it as it's not like a traditional company where you have like an information technology department.
Yes.
Like AI, and people who possess a background in AI and machine learning are going to be embedded everywhere. Mm-hmm. As time goes on, they'll become more and more prevalent. It'll be more and more, less and less a desired skill and more a required skill. So that this mindset can be applied to all problems. So I see it. I see the future is really bright for this industry.
So I guess unprompted, I would love to hear Dr. Parkey's opinion on this. Considering your background with working with systemic level issues, and how can we avoid, again, we're talking about workplace automation here ultimately, and how can we avoid some of these traps that the folks are worried about?
Yeah, there's I have a practical article out about this, but you want to take a look at every stage of the process. Dr. Jaffe brought up that companies are doing a great job documenting what their principles are. And then you have to take a look at how you apply that across the board. So it may be impossible right now for you as a data scientist to measure some of these biases and impact before you release your model into the world. So what needs to change before data gets to you in order for you to be able to do that? What needs to change about the systems that we have in place? And we have to take a look at that from the data that we collect, from the way that we expose the data, from the way that we decide to fund a model or fund a question and send people to it, and how do we release whether it's side by side a model that we want to change and measure what it would have decided before we put it out there. There are all of these ways that if we take a look at every single point in the process of applying those principles with systems, then it doesn't require any individual's passion or belief to make it so. And so, we do these retrospectives all of the time when something goes wrong. How did we get here? And it's not about blaming an individual person and like firing them because like you had an InfoSec breach, right? Because there's my data has been stolen like 20 times at this point in my life. The number of breaches, like it's insane. Everyone has my social security number. It's more about what were the series of things that had to have happened that failed, and how do we fix the system itself? So we're seeing more conversations around that because to your point, I think the person who asked the question about should each individual be trained in ethics, sure, that'd be great. But you need to be able to have all different people from all walks of life using AI. Like that's what we're going to be seeing. And not everyone is going to have had a chance to do that. So you have to integrate it. You have to integrate it at every step. You have to say, yep, at this point, you're going to be measuring this. Here's what it is that you're looking for. And this is what is acceptable and this is what isn't. And so we're seeing a little bit of that shift in some of the processes that companies are putting in place, but it also needs to be in the systems that they're using.
So I guess from a system perspective, I do have a question here from an audience member, and it's I'm going to paraphrase here a little bit, but if there are system level issues, and ethics does overlay with that, can any of our panelists provide examples of how, while in your working lives, if you've share an example of how you've had to sort of lean on your own ethical principles while working on groups, or like team projects in your companies, or interfacing with external stakeholders or clients?
Let's see. I can start with that. It's a very silly example, but and not something again. I would say that, like Dr. Parkey was saying, it's not the obvious on what is not ethical, right? Whether at work or outside with the AI. It's very, and I love that this question is asking for a system level kind of a solution. So I'll give a very simple example. We all, or most of us have cars, right? And we have to maintain our cars. And so when that little red light, the maintenance light goes off, me as a female, my reaction and is much different than what my male counterpart's reaction would be. And so I'm going to get there from an ethics perspective, right? But that is because now I have to take my car to the shop and I have to trust a very male dominant field that is filled with male mechanics, right? So now I have to trust somebody, and the list that females get, no matter how technical, or how we can flash our PhDs all we want in electrical engineering. No, the list that we get is very different than a list of. I mean, I've sent my male colleagues sometimes in, or my friends, that can you take my car in, because I know that they just will give you a shorter list than what they'll give me. So I guess the point here is that this little red light, right? The automobile industry is very much male dominant as well. Not enough women in engineering, right? So if I was designing that little red light, I would have put some explanation to it. I would have said that now your filters are going bad. Do not let them change your spark plugs. It's not your spark plugs, So I would give me one less AC vent, but give me the room for this explanation, right? That's what a female would say when we talk about building. And this is just one little red light in the system of building a car. So that's why now let's say that if that company now, if the car company puts AI on top and builds more automation, that now the red light goes and now it's telling you which mechanic to go to, that doesn't help me. I'm already concerned from that little red light. Don't just add layers of AI to this when there's a root cause to the system that's designed without diversity in mind. So it's a system level problem when it comes to engineering solutions, that we have to have a diversity in mind to begin with. And it's not obvious, like the car companies don't think about this stuff, and that's why, so it's you go to the core of the design process and design, and you have to iterate it, with that, and then put AI on top. So that's probably like the closest I can say from an ethics perspective, that nobody relates that to ethics, but it's when people get cheated on what is wrong with their equipment, is something that is ethics related, and it could have been solved had it been tackled to begin with diversity in mind.
I think even worse is, so yes, maybe they didn't think of that, and that is a problem, but probably worse is that they did think of abstract or obfuscating the information on purpose for capitalistic reasons, which is, ethical problems for a different, different reason.
I have an example of, so a lot of companies out there, when they're building AI, they are having to collect data from customers to make a more generic model. So my last startup, Textio, builds machine learning models to help you write job postings, recruiting mails. I'm sure they do other types of writing now too. But when you are writing a job posting, how do you know that the words that you're using are not going to disproportionately attract different demographics, attract more men, or push away women, or there's a whole ageism aspect in there. Like you think that like adding an 80s lyric in there is cool and funny, but like it only resonates with a certain group of people. And there's all of these different types of coded language that you find, not just it's not a global trend, right? You've got global trends for sure, but then you've got individual industry languages, and then you've got individual location languages. So the way that I talk in Seattle is very different than you talk in Silicon Valley. So in order to build these models, we have to not just collect the data from our own users, right? You're a startup, you start with like 100 companies, and then you get to thousands, but that's not a representation of the world or of language. And it's not enough to just go scrape language in order to build this kind of model. You need the outcomes too. And so one thing we would run into is that each time we got a new customer, they would provide us data in order to make the entire pool better for everyone. So one ethical thing that some customers didn't understand is there are other products out there that you can use to predict someone's gender or ethnicity based upon their name or other information in their resume. And they thought that it was better to guess in order to understand if they were disproportionately treating someone than it was to ask. And that if you propagate that data through to our models, like that, I can't accept that data. I cannot add data into our system that reinforces biases by another model that is predicting someone's gender or ethnicity based upon other information. That is not okay. So at the very moment of collection, we had to do a lot of questions of how the data is collected. Is a person allowed to choose not to answer? You know, there's a lot of things in there that we had to make sure were in place so that people weren't guessing. And we had to turn away customers' data because they were guessing gender based on someone's name or on their photo.
So thanks for that. I'm just time checking myself here. We're getting close to the end of this panel. I do have another question here from the audience. I'm going to float. This question is for the entire panel, so I'll read it here. There is often forgiveness on the lack of model interpretability for unstructured data models, CV, NLP, and for other general recommender models. For prescriptive models supporting internal business decisions, making sure there is still a desire for executives to understand the drivers of the model to inform strategy and product development. What progress are you seeing towards machine learning AI models that are both highly accurate and highly interpretable?
This is a tough one. I think that one of the reasons why there seems to be forgiveness on lack of interpretability for things, especially NLP, is because folks weren't necessarily seeing the consequences of that lack of interpretability. But if you look at OpenAI's new API, they did their own study when they released the API to say, you know, here's what we're seeing in terms of bias that it's showing, right? They're holding themselves accountable to what is possible. And now they're requiring people to apply to get access to the API, and you have to tell them what it is that you're going to do with the model. And then they reserve the right to remove your access if you do something nefarious with it. So you can think of a healthcare situation where it is entirely possible to build bias into service healthcare based upon how someone writes about someone who comes in for health. And because someone may be interpreted as not sick enough or something like that and turned away, that can get encoded into who gets care. And so we have to be very careful about this. So some of the progress that I've been seeing is more around the company level when they're releasing these tools and restricting them. It's just beginning. A lot of people just open source things and then they like give it out, and people you can't trace that. The use with APIs you can. So I'm seeing a little bit more for uninterpretable models where it's more of a license to use something than it is you just get access to the source code. And then the other side of that is, you know, I'm hearing more and more questions about the trade-offs. So sure, this model number one is more accurate, it's going to make us X number of dollars more, but tell me why, tell me what goes into it, because it's not enough to know why there's more money, because that could be a short-term gain. You need to know what's going on. And so there are questions coming from executives, from revenue leaders around, you know, what's it coming from? I don't think it's enough. I think we need more progress here, but that's what I've been seeing.
Okay, well, thanks for that. Again, I'm time checking myself. If there are no other quick questions from the audience, I'll pause for another moment. Okay, so again, this has really been a fascinating discussion, and I really want to thank all of our esteemed panelists and our wonderful audience for participating in this Zoom session today. You know, I really hope that you all you know, learned something from this. I know that I did. A fascinating discussion, and you know, as you'll see in the upper left-hand corner of your screen, we have been recording this. So we're going to be sending out a post-event email that'll also contain a link to the recording of today's panel. And in that email, you'll see a survey for this event. So we want you to stay tuned to the symposium for more great content and panel discussion coming up. So at this time, I want to hand the mic back to our MC for the next session in today's schedule. Thanks everyone for participating.
Thank you.
Thanks.
Thank you, panelists. What a great discussion. We would like to take this opportunity to hear a little bit more from our sponsor, Intego Group. Please welcome Ken Roby.
Okay. Thank you so much for that introduction and the opportunity to speak to the entire audience today. My name's Ken Roby, and I'm in our sales and business development group with Intego Group. I have a few minutes today to speak with you. I want to touch a little bit on the industry, our organization, the successful partnership with UCF, why we sponsor, as well as the offer to you graduates with a paid internship, which we're offering to lead to full-time employment. We really value this partnership and look at this as a partnership with UCF, and we're blessed to have such a strong academic institution here in our backyard. It's important to us at Intego Group to have this program in place to be able to provide the technical resources required to the pharmaceutical industry. This partnership includes, as I said, a paid internship, which is 3 months that will lead to for qualified graduates into a full-time opportunity with our organization on one of our statistical analysis teams for a pharmaceutical client. What we need from you all today is we need, with this format, obviously we need to have your resumes, your contact information. So if you have a CV, great, but if a resume, just some information on your educational background would be ideal. And if you can email that to us, that would be great. Our email address is UCF@Intego, INTEGO -group, GROUP.com. This morning at the breakout session, it was very productive. Met a number of you and had some really good discussion. We also this afternoon have a networking session that hopefully you'll be able to join. But if not, please forward us your contact details to that email, or you can also look on the UCF site for the symposium, and our details are there as well. But Intego Group, we're a global biometrics clinical research organization. We're headquartered in Orlando and Maitland. We have global offices in Europe, in Ukraine, as well as recently expanded into Poland. We're supporting the pharmaceutical industry and their clinical trials, and specifically the statistical analysis of those trials. The statistical analysis is a critical aspect of the clinical trials process, reviewing and making sure that these drugs are safe and effective for humans. One of the things I'll mention is that I think is universal among those in the industry is personal fulfillment with their jobs. We're working on drugs on a daily basis that improve quality of life and also save lives. Whether that be heart, cholesterol, cancer, COVID vaccines, knowing that every day the work that you're doing your own little part to help to save lives is quite motivating. And I know there's a lot of different opportunities for you, and it's a wonderful time in your lives. But I think personal fulfillment is one thing I hope you consider with your next direction in your career. The pharmaceutical industry has been experiencing significant growth year over year for the last 20 years. With that growth, there's lots of opportunities, very attractive opportunities with different career paths that you can take. One of the challenges that the industry has faced is with that significant growth, they've had challenges with supply of highly qualified technical resources. And so we at Intego Group, to meet that demand, have implemented various training programs across the globe, just like we're doing with UCF. We're in our second year, and it's been very successful. We've been doing these training programs for over 9 years, adding many programmers and data managers to the pharmaceutical industry on an annual basis. And with that, I'll just leave you with, this program has been very successful. We're excited about the partnership with UCF. I hope you'll consider a career in the pharmaceutical industry and with with us at Intego Group. The opportunity is full of personal and professional and financial rewards for you, and I hope you'll consider that. If you have the opportunity, please stop by this afternoon and talk to us in our networking session. If not, please forward us your resume for an opportunity. And thank you so much for your time, and I wish you all the greatest success in your careers. Thank you.
Thank you so much, Ken. We appreciate the continued support and student opportunities from Intego Group. Speaking of the afternoon networking sessions, we wanted to remind everyone that the links have been updated. So instead of using the previous links in your email, you'll use the new website, which is currently in the chat. And please join me again in welcoming our department chair, Dr. Shampu Zhang.
Good afternoon. It's glad to see you again. In the afternoon, OUC, our sponsor of the data competition, will announce the winners. How exciting it is. OUC has been a great partner with us, and it's absolutely my pleasure to work with the OUC team, especially Eddie Fee and Don Fry on these projects. Their team putting a lot of effort, a lot of work to provide our students the real big data. This competition has provided our students a real working experience in the business and the industry. They all have learned a lot. This competition has also brought together students from all areas of data science at UCF. So from students from all the data science programs at UCF could participate in this competition. And look into the future, if your company is interested in sponsoring a competition or building a partnership, please let us know. And also please make sure to visit the networking session to meet our symposium sponsors at 3 p.m. Next, it's my pleasure to introduce our Senior Associate Provost of UCF, Dr. Tim Lazier.
Thanks, Shampu. It's great to be here, and I want, on behalf of Provost Johnson, who couldn't make it today, and as well as our president, Dr. Cartwright, I do want to welcome you to the Big Data Analytics Symposium hosted by UCF. Obviously, we're in a different situation, so we can't welcome you normally to the sunny section of Central Florida, but I'm delighted that we're able to adapt and pivot and offer this symposium in this way. It makes sense that we're the kind of the host here. For me is, we have programs in big data analytics. We have the doctoral program, PhD. We also have a master's in data analytics, as well as the brand new BS in data science, which I had the pleasure, as I'm in my 18-month here at UCF, I had the pleasure to work with Dr. Zhang and his team in the implementation of that program that was recently approved by our Board of Governors. You know this, but I find the interdisciplinary aspect of this burgeoning field very exciting. This interdisciplinary aspect is perfectly illustrated by this symposium being, co-sponsored by our various colleges, College of Science, College of Business, and College of Engineering. and computer science. And all of these house programs connected to data. I also want to take this time to thank OUC, Bull Ridge, and Intego Group for their sponsorship and meeting with our students. Our student success is primary, and so helping them find internships and jobs is very important to all of our roles, as well as Playfair Data and Milliman for their sponsorship. I come at data from my legal background, as well as working in higher education for over 30 years. One of my favorite court cases to talk about with students is the McDonald's hot coffee case, which took a life of its own in the Seinfeld episode when Kramer spilled hot coffee on his legs. If you haven't seen the episode, you probably need to see it. What I find interesting is most people were confused by that case because the person got a $2 million award for spilling hot coffee on them. They actually didn't get that much money. We don't know how much money they got, but they didn't get that much money. But it was data that won that case because the plaintiff's lawyers went to the local emergency room of that McDonald's and found employee after employee after employee over a certain number of years, all being treated for burns, serious burns from the hot coffee. And it's data that's going to continue to have that type of effect on things that we do. And it is very interdisciplinary. I could not imagine the things that we're doing with the data now, both in higher education and other fields, from the predictive analytics that we use in advising our students to all the AI growth across the world. And we're getting both those intended and unintended results, some good, some not so good. But that's why we come together at opportunities like this to learn and grow in our knowledge. And as the leading research university in the field, I was very encouraged by the conversation that I was able to join, especially between Dr. Parkey and Dr. Jaffrey. Yes, ethics are very important. Just as lawyers need to take ethics, probably those working in big data need to find some ethical training as well. So I'm delighted that we could assist in this endeavor. Thank you for joining this symposium, and I wish y'all great success in your futures. I'll turn it back over to whoever is next. Y'all have a good day.
Good afternoon, everyone. I'm Manju Pollacket, the Chief Transformation and Technology Officer of the Orlando Utilities Commission, the sponsor of the OUC-UCF Meter Data Science Competition. OUC provides reliable and affordable electricity and/or water services to more than 240,000 residential and commercial customers in Orlando, Orange County, and St. Cloud. This also includes the University of Central Florida's downtown and Lake Nona campuses. Altogether, OUC is connected to more than 400,000 metering points, and each is a source of granular data that we collect, aggregate, analyze, and if warranted, act upon to better serve the customer. Quite simply, we no longer manage our business on intuition and experience. Data is at the heart of everything we do, and it drives almost every business decision we make. Whether it is marketing, finance, customer service and outreach, efficiency programs, electric vehicle charging consumption, energy and water demand, sustainability initiatives, grid resiliency, our carbon reduction goals, and so much more. Everything we do relies on our capabilities to leverage data as actionable information that could enhance our strategic plans and improve services to the communities that we serve. For example, we use customer data to spot anomalies, such as spikes in their energy and or water consumption, which could be caused by poor insulation, inadequately maintained AC units, failing appliances, inefficient lighting, or leaks in irrigation or indoor plumbing. Many times our customers are not aware of their extraordinary energy or water usage until we notify them and show them the data we collected through our automated metering infrastructure, which is an integrated system of smart meters, communications networks, and data management systems that enables two-way communication between utilities and customers. Armed with this customer data, we can help them identify and repair the source or sources of a spike in consumption, saving them money on their utility bills and reducing usage. Last summer, OUC launched the Meter Data Platform, a new state-of-the-art cloud-based data platform that helps our meter operations team manage and analyze a more robust repository of information gleaned by our automated metering infrastructure. This new technology provides a suite of tools that can quickly mine and analyze large sets of data and provide actionable insights. Our investment in this platform is another proof point of the importance of accurately reading and reacting to data, as well as using data to foresee trends and inform decisions that will better prepare us for the future. Speaking of the future, OUC is undergoing perhaps the most transformative time in our nearly 100-year history as we begin to build a cleaner, greener energy grid. Last February, we declared our commitment to reach net zero CO2 emissions by 2050, with decarbonization goals of 50% and 75% in the preceding 2 decades. Solar energy, battery storage, electrification of transportation, customer efficiency programs, new emerging technologies, to name a few, will all play significant roles in our transition. But we would be guessing at the efficacy of any of these initiatives if not for reliable and actionable data. That said, the value of the data we collect depends a lot on the skills of the people who manage it. Well-educated and expertly trained data analysts are in high demand in the energy industry, which is why we're very excited to be part of UCF's Big Data Analytics Symposium as the sponsor of the Meter Data Science Competition, which you'll hear more about shortly. Your participation in the symposium could lead to a career in data analytics or a related field. UCF is an extremely valuable partner with OUC, and we have a history of working together on all kinds of projects. Currently, we're partnering with UCF's College of Engineering on a project that is helping us gauge the impact of cloud cover on our solar energy production. In return, aspiring mechanical, computer, and electrical engineers are getting real-world experience working in an industry-leading concept that relies heavily on data analysis. It is incumbent on us as Orlando's hometown utility to collaborate with Orlando's hometown university because we share a common interest in making the world a better place to live. And data will help both of us do that. I hope you find the symposium beneficial to your aspirations, and to those entered in the competition, I wish you the best of luck. Thank you very much.
Good afternoon and welcome to the UCF Meter Data Science Competition. My name is Eddie Fee and I'm Director of Meter Services here at OUC. We are very proud to be this year's sponsor for the annual Big Data Analytics Competition. It's hard to believe that a little over 1 year ago, OUC participated in the 2020 Symposium as a prospective employer. After seeing the great work of the students that participated in that competition and meeting Dr. Shumpu Zhang, we were eager to get directly engaged in the data competition aspect of this symposium. We certainly would have never guessed at that time how COVID would have impacted us all, including the need to conduct this symposium virtually. But here we are, yet again adapting. So, in partnership with UCF, OUC kicked off this Meter Data Science competition in September of last year. UCF graduate students from various programs, including Big Data Analytics, Statistics, Data Science, and others, were given the opportunity to access and analyze real OUC data, electric and water metering data, and to collaborate with OUC subject matter experts to help solve real problems, otherwise known as use cases. Students formed teams of 2 to 4 each. Initially, we had 15 teams join this competition. Each team was assigned one of 2 unique use cases to work on. Generally speaking, the student teams were asked to 1. Create tools and models to address the findings and results of their use cases, consistent with OUC needs. 2. Document and present processes, justifications, and instructions for the tools and models that they utilized. And 3. present their final findings and tools in layman's terms to the OUC team. Now I will pass the mic over to Dawn Fry, OUC's Manager of Smart Grid and Meter Data Management, who will share more details on the assignments given, the data utilized by the students, and the results of the competition so far.
Thank you, Eddie. Before we announce the winners, let's walk you through a little bit about the competition. OUC recently implemented the Meter Data Platform in June 2020. It's a centralized location for all of our smart meter data. As our journey continues, this competition provided OUC an opportunity to begin applying advanced analytics to solving business problems, which in turn enhances our customer experience. OUC is both an electric and water utility, and the data provided to the students was over a year's worth of data. It consisted of 15-minute incremental electric consumption, hourly incremental water consumption, 15-minute voltage values, and various meter alarms, alerts, and notifications. The teams were split into 2 use cases. The first use case, EV, electric vehicle detection. The objective was to identify the addition of charging within OUC's service territory. By looking at electric consumption and other variables, is it possible to identify and answer a few key questions? Predict future EV penetration by geographic area, identify electric distribution transformers most likely to be impacted by the current and forecasted EV penetration, offer EV rebates and target market other programs such as rooftop solar to this unique customer segment, and understand how time of use or other pricing strategies could help change consumer EV charging behavior. The second use case was utility theft. The objective here was to identify outliers indicating complex theft and tampering situations. What's interesting about this situation is the meter typically doesn't trigger an alarm or notification. The idea behind solving this business problem with analytics is to provide OUC the ability to calculate and leverage water and electric usage ratios to identify theft by region, subdivision, and other data subsets. Also, identify incorporating contributing factors and a correlation that would increase the likelihood of theft and tampering at a particular premise within a region, and also then presenting these findings and observations with visualizations and scoring that would allow the field personnel, the revenue assurance field personnel, to effectively prioritize their investigations. So once the team assignments were made, we conducted regular virtual meetings with the student teams. They had access to the OUC subject matter experts through a Q&A throughout the project. On February 1st, written reports were submitted to OUC for review and scoring. And later in February, the teams each presented virtually their project approaches, observations, and recommendations in a 15-minute presentation. So here we are today, where all the hard work put forth by the students, the professors, and OUC culminates into the recognitions and the awards. Let me turn it back to Eddie for some final comments.
This competition is another example of how OUC is working to attain additional value for our customers and operations by leveraging our investments in automated metering infrastructure, smart grid technologies, and the cloud-based meter data platform, as well as partnering with local universities. In fact, there are 2 current OUC employees, Darren Reynolds, Analysis and Reporting Specialist, and Kristen Castres, Associate Data Analyst, who both were graduate students from UCF that competed in this very same big data analytics competition from prior years. And they were both a critical part of putting this whole thing together for us this year. I thank you both, and I thank everyone else on the team who made this day possible. To the students, we sincerely thank you for seeing the value in this competition and for the experience, and for continuing to forge ahead in spite of the challenges that COVID presented you Job well done, and go Knights. Up next, we'll hear directly from some of the students. We'll get a sneak peek into some of their projects, and ultimately, we'll find out who the winners of the 2021 Meter Data Science Competition are. Stay tuned.
We're presenting today on this 2021 OUC Data Science Challenge in partnership with UCF, and we wanted to extend a special thank you to OUC for extending us the opportunity to work with this project and work with this data. It's truly been very exciting. We also want to thank UCF and Dr. Shea for including us in our Masters of Science in Data Analytics group. We worked on the electric vehicle case study, and today we'll be introducing the problem statement that was provided to us by OUC and the specific areas of which we decided to tackle. We'll also be discussing our exploratory data analysis, kicking things off, discovering some things about the data, and some results that we were able to provide back to OUC. We'll also be discussing our modeling, including the subset of data that we defined as good meters, or meters that we identified as potential candidates for having electric vehicles charging in their homes. We'll then move into a preliminary analysis and some of the initial modeling that we did to explore the data and to tackle the specific problems. And we'll finally introduce the final model we developed, which is pretty accurate, the domain knowledge model. And then we will close in providing our recommendations back to OUC in how to adjust their charging station infrastructure and how they can plan out their user charging behaviors and consider loads to their network and to their grid. So the problem statement, we were provided with kind of a long list of different things to tackle. The first thing that we figured out is that OUC was kind of struggling with the general understanding of some of their smart meter data, especially as it relates to whether or not an electric vehicle is there. We received this large Snowflake data set. We went through a lot of tables, and we identified the columns that we thought were valuable and relayed that back to OUC. And our specific goal that we decided to focus on is identifying who is charging an electric vehicle in their residence. And what are kind of their charging behaviors? Do they charge at specific times or not? Because that kind of information will impact how electricity is being stored and used on the grid. We then discuss predicting future EV home sites by geographical area. So this is kind of determining where might electric vehicles be coming into the market soon, and how should OUC kind of budget and allocate their resources around that. We did an analysis on the impact to transformers based on that incoming EV penetration. And we also looked into a grid overload mitigation plan, determining how they should, again, allocate their resources to counter that. And finally, we even kind of dabbled a little bit in looking at some other household appliances that might even look like an electric vehicle, but are just high power consuming appliances. This is a brief window on exploratory data analysis. We provided a few Tableau dashboards to OUC. And you can see those on the left. They are interactive bubble charts such that when you click on one bubble, you're essentially filtering the other bubbles to that level. And it helps to give an understanding of the specific data within. And what we're seeing there is it's actually related to fact status, which kind of bleeds over into the other case problem of the theft detection, and may be applicable to look into for that. Over on the right of your screen, you'll see the what looks like an Excel spreadsheet. This is a brief snippet of the data dictionary we provided back to OUC, where we identified the features in each table that we felt were most relevant, applicable to a kind of machine learning analysis, and things that we considered were not important to our analysis.
Yep, so I'm just going to go over what we mean by good meters. This was just the term we used when discussing the meters we were using for training and testing. So as Dan mentioned, we were looking for single-family residential homes. So of the 244 labeled meters given to us by OUC, the logic we used, which is defined below, filtered that down to 142 cases, which we were sufficiently confident that represented residential homes. And that logic was essentially one of the variables or features, current flag, indicating whether that meter was currently being built, was set to true. We looked for the SP type CD, set that to ERES, looking for residential. Then we also filtered based on latitude and longitude. Our preliminary modeling after EDA gave us back some really varied results. So the simplest model we looked at was some K nearest neighbor using Euclidean distance as the metric. And without a whole lot of data cleaning, just to get an idea of the base model, that gave us an accuracy and precision and recall were all relatively similar, right around the 60% range. And we found that the K equals 8, so the number of neighbors around 8 gave the best performance. So then we moved on to K&M with dynamic time warping. So that was actually very interesting. Dynamic time warping is a different distance metric, and that actually held what looked like possible value. However, it was very computationally inefficient. So we moved on for that because we understood that the problem was something that needed to be solved in not simple terms, but in efficient terms. And then we also did a single layer classification neural network with the 96 input nodes representing the features. And that produced approximately 70% accuracy, precision, and recall. So that was, of our preliminary models, the best performer.
So the domain knowledge model, what we really mean by then is we took advantage of knowing what power is. So power is voltage times current. We know that level 2 chargers use 240 volts, and we kind of have an idea of like how much current it's pulling. So we were able to set a max power limit to interval records. Knowing that, we also know that when an electric vehicle is in charge, it's consistently pulling power, right? So that's another thing. We have duration. So we built a model based off power and duration. And what this had done was it increased our accuracy to 81%, beating the classic machine learning models. And it also increased our precision for finding true confirmed EVs in the labeled data set. So that's kind of how we built our model. And then once we were finished, we went ahead and we plotted the results against the fact interval table, and we got the max demand. And we were able to kind of see that on average, a confirmed EV or even a rebate has a higher max demand, and that's how we found our sample set for our test data. We can see that from this, we were able to randomly sample based off that, and then running those meters through our good meters qualifications, that left us with 944 meters to sample and run across our model. As you can see here, the orange, we have 167 meters that were classified as having level 2 chargers. So it performed pretty well. And then from this, we were kind of able to develop recommendations. So we also pulled external data because we kind of wanted to see where level 2 chargers or where homes were in relation to actual charging stations. From the yellow, you can see the predicted EV customers, and the green are the charging stations. And if you look, you can kind of see there's a whole untapped market within the St. Cloud and the Lake Nona area. We also wanted to offer you guys competitive analysis. So we went ahead, and if you look at the chart on the right, we separated the stations, the charging stations, by other stations that were non-OUC and charging stations that were OUC. So you can kind of see where you are in relation to your competitors. If you look at the column 1, those are the number of labeled EVs that were given to us in the neighborhoods that were provided in the Orlando zoning shapefiles. And then if you look at the test, you can see those are the number of meters that were found in our domain knowledge model. And there, as you can see, we have like 60, and that is most likely within the St. Cloud and the Lake Nona area.
So for the recommendation part, we have 3 recommendations: charging station infrastructure, solar, and the time of use program. So as Anna mentioned, that we can see from the graph too that over the I-4 there are many charging stations, but in the near the Lake Luna and the St. Cloud and other areas, as seen in the graph, there are very few charging stations. So this can be achieved using 2 things: either OUC install their own or reaching out to commercial customers and use their parking lots. So if they offer commercial customers, that commercial customers are also getting the tax credit up to 30%, and that will bring more customers to their business. So it is a really good idea to reach out to commercial customers of OUC to install the charging station in their parking lot. And also near the Turnpike exit, that will be the good location for the local residents as well as the travelers. So those are for the charging station. And the second recommendation is for the solar. So we can divide this data or the customers in two parts: EV, non-EV, and it can be further divided into 2. So EV owner with solar, without solar; non-EV owner with solar, without solar. If the non-EV owner doesn't have solar, then we have from the data that solar homeowner average reading score is 236, while non-solar home is average reading is 244, which is higher than the solar. So the heavy usage customers can be reached out, and they can be get advantage of the rebates and the solar tax credit to install the solar in their home. On the other side, EV owners are more likely to install solar based on their consumption, and their consumption is higher because their average reading score is higher than the non-solar home. So OUC is also providing the rebates, and they can be incentivized using the time of use program, because from the data as well as from our model, we have observed that there is a very good pattern in the charging behavior. The pattern is they usually charge from midnight to early morning, and this is a very good time for to reduce the load on the grid. So we recommend that if OUC can initiate the program in Florida, which is time of use program, where they are providing the lower rate to the EV customers to electricity at a lower load. So that will help reduce the load during the busiest hour when increase in EV sales are increasing, and it will train the customers to charge the EVs during this time and maintain this behavior. So these are all our recommendations, and thank you for opportunity and the time. We really appreciate it. Thank you.
Thank you for this opportunity to present our work for 2000 OUC Meet Data Science Competition. So this is the outline for our presentation. We take part in the Case 2 competition. The goal is to identify electricity, the shift tempering, analyze OUC, the meet reading data. We designed two objectives. The first is to find the outlier of ratio of water to electric in monthly consumptions for each parameter ID. And the second objective is to estimate the chance of shift in daily consumptions for each meter. The data source is from the Snowflake database, include 8 datasets. I listed the information in this table. After we export the data, we select the two datasets. The first one, DM installed meters, and the factor restructure. So why we select the two highlighted datasets? The first data provide the demographic of meters compared to the third data. They provide more details like the parameter ID, location, and the coordinate. So we select the first data for the demographic of meters. For the daily reading data, we select the factor restructure. Compared to the last data, factor interval, because we only interested the daily consumptions for electric and water. We don't want to need the details of the reading point or factor interval. So I choose the factor register as the daily reading data. We use the Python software and use the package Snowflake connector to connect the access the database, provide our user information and database information we can access from our software to the database. And then we create a cursor. Cursor is like a SQL server. Use the cursor, you can execute the query. So we define the download function. And after we use the query and use the cursors to execute the query, and then we use the appendix functions, convert the tables to our the data frame of the Python, and you can serve this data in your local computer. In details, for the first data, we download all the information because it is small, and it served it as one data set. And for the factor register data, because it is a huge site, if we download all, they have the issues of out of memory. To solve this problem, we split it into electric and water part, and also we split the data by monthly. So there are totally 8 monthly from the April 2019 to September 2020. And you can see there are total 36 data parts to store this data. And to download the 36 part, you need to design your queries. And in addition, we use the format further to serve our data. Compared to CSV and Excel, further is night and valid communication for large data. So that means you serve and loading data very fast use this format. And this slide shows you details of how to design the query in download the 18 electric daily data. As you can see, the highlight, we identify the types of electric only and the consumptions, and identified KWH, UM, and we use the dynamic the parameter year and month to download the different year-month data, and we call the function A, previous function download data to execute this query. And there are total 18 data for the electric daily part. And the same idea to download the water daily part. And this time, in this case, you identify water only and use the unit GAL in the UM. So also you assign the different value of year and month. You can download the different the water daily data. There are also total 18 data set. So this is our data set. I can summary. So we have one demographic data and 36 of the daily data. Our method is to calculate the ratios of water to electric amongst consumer level for the climate ID. So to identify the outlier of the ratio, we applied the 1.5 times IQR rules. This is the statistical rules to how to identify the outlier. The first data, we split the data two parts. One is for the electric demograph, one is the water demograph. And we keep 6 variables: meter length, the climate ID, the location, and the coordinate. For the second data, because we need the consumer in the monthly level, so first we convert the daily data to the monthly level data. This is the details how to our technologies to convert the daily meter to the monthly consumption data. First, you reading your data, and we have the subset keep the 3 variables: meter length, reading date, and the reading. And we have cleaned the duplicate observations and sort the data. After that, we generalize the variable for BM months, keep the months and years information from the reading date. At the purpose, we want to group the data, use the meter length and BM months. To calculate the months consumptions, the idea is we find the first reading of this month and find the last reading of this month, and we calculate the difference between the last and the first reading. And we treat these values as the monthly consumptions. So we use the variable kWh to store the electric part, and KTL to store the water, the meter monthly consumptions. And when we use this method, we have some issues. Okay, I will describe these issues in next slide. So we have additional step: clean these 2 variables. And we can repeat these steps, the function DOE for next month. We obtained the 18 the monthly consumption data, and then we convert all the data vertically. So we get 1 data for the electric, the monthly consumption data, and 1 data for water monthly consumption data from the 18 the daily data respectively. And what's the issues? We use this method. We have elective monthly consumption. We calculate the difference. So I've used 2 examples. How do we fix the problem? For example, the case 1, when we calculate the meters, the difference. Suppose we have the two values. The first one is the first reading, 99998. The second one, 1147. Is the last the reading. So when we calculate the difference, so the huge we get the negative the huge one for the monthly consumptions. Because this is the issues of you meet digit 4, so the meet digit is reset to 0 and continue the reading you. So we fix this problem. We can add the 1 million for these values. And you can get the the monthly consumer 1149. And this is we identify the types of mid digit. So 2 types for the electric and 3 types of mid digit for water. We can fix the problem for this case. Another case is the reading gap. This time is not due to the meter digit 4, but we still have the difference. Elective. Actually, the data looks like this. The data has some part of large reading and some part of the smaller reading. Between the 2, there may be the break 10 days. I don't know the exact reason. Maybe the change account or the meter damage. You fix it and reset it. So in this one case, we identify to special the data for this month, and we calculate the lag difference That means, for example, 222 from the second one and the first one. And we use the 0 to replace the negative difference between the gap. We don't know what exactly the consumer is in this state, so we replace 0. And we use the summarize of the difference to replace the monthly consumptions. So replace this value with 480 for the negative. This shows you the examples how do we fix the negative cases we calculate the month consumptions. After that, we merge the data. The flowchart show you how we merge the data. We have the monthly consumer data, merge your dim graph, and get to your meter level, and we aggregate the data to the pre-matched level. Because a pre-matched ID has the several meters. And when we merge the data, we have this case. Okay, when the pre-matched ID has a water meter, you have the KGL. That means you have water values. But the pre-matched ID hasn't the water meter, the KGL you are missing. And to find the compatible water information for those the pre-matched ID without the water, we developed the method what called the geography match. So we match the water pre-matched ID to the electronic pre-matched ID. So assign this information coordinate. So we assigned this water information for this pre-matched ID and the water meter. And also we generated an index water meter. That means yes or no. So you can identify this pre-matched ID has water or not, has true the KGL or compatible KGL. After that, we get the one data with include the variables pre-matched ID, BM months, KWH, KGL, and you can calculate the ratio of KGL and KWH. And our statistics, the details of our statistics. So you can get the ratios and you apply our rules, 1.5 IQ rules. We can calculate the output equals the third quartile plus the 1.5 IQ. If the value ratio is larger than the upper bound, we put this outlier. That means this is potential of shift. So this is the second data analysis methodology of we identify the daily electric consumptions. The idea is from to calculate the slope trend. For example, this is winter speed. We calculate the slope trend and compare the slope trend. We can determine the shift the potentials. So the data preparations, if you put a meter length, we can identify the meter length, the details of daily information. And we can calculate the slope, use the linear regression, calculate the decrease of slope trend, and calculate the t-score, and convert it to the consumer trend.
We never really done much classes on this before. We learned here and there in different classes, but not much application. With this large data set, with this many requirements we need to do, it provided me a really great opportunity to really learn how to use SQL correctly and to source it correctly.
And using a model that's built on logic based around the chargers, and then saying, well, this performs better. That was a big insight for me, because I think everybody wants to just kind of you learn machine learning, you're like, all right, I want to apply it to everything. I want to do this, I want to do that. But, to take a step back and say, well, you don't always have to do that, just find what works best, and you can, define it well, and it performs well on the unseen data, then that's great. That's perfect.
The real usage of this competition is to help us to think through the problem, and in a real world setting, that it will help you to validate if our approach is good or not. And then that's really the business part that's gonna come into place.
We gained a great meeting of friends and having fun with new data. Getting to deal with data that is actually real and a real situation is perfect, especially since we're used to theoretical situations with like research. It's just it was a great experience.
I work with my colleagues like Roy. It's our first project mingling, our first project work together. So it's nice work with you and my classmates.
I never really kind of imagined how I could use how electrical information is actually relevant in data analytics. So for me, it was kind of cool to see how I could use data for my day job. So that was really cool.
This project really gives us an industry level experience. So now if you can just look back at my resume, it just adds me huge asset to my resume. So whenever I attend interviews, I'm able to confidently tell about this project. It gains attention for a lot of recruiters out there.
It was super fun, really, really awesome. It was nice playing around with data. It was nice doing research in environmental area.
We have experience to handle the large data, and how to do the business problem.
I learned that data is so important, data cleaning is important, and taking a sample and from that predicting everything, which is amazing. Thank you for the opportunity.
We have learned how this is gonna affect the business and how a particular product owner is gonna lead into a surplus using a particular product. That was something I learned out of from my technical experience while doing this project. Like in a business perspective, how it's gonna help.
I love the data. It's like very large of data set from Snowflake. Thanks for all of you guys. You helped us so much. You answer many questions. It's like you open my mind, open my idea.
We appreciate that we have the flexibility to come up with creative ideas to handle the real life problems. For me, this competition gives me the opportunity to learn to use dashboard.
It's an honor and a privilege to work with this real world data and get to actually do what we're learning about doing in our classes, right? We talk about doing these different models, but the end goal in mind is always to add value and provide value to a company such as OUC. And getting to do that with all of this real world data, diving in, modeling, using everything we've learned in school with the end goal of how does this better serve the end customer. That was my favorite thing about this project.